Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of your screen. Wherever your Zoom controls are, you should see a little button that says Q&A. Click on that, type in your question, hit submit, and I'll get to those at the end of the session. If you're watching on YouTube, just feel free to use the live chat function wherever it is on whatever device you're using to watch. So my name is Jason Gabrinas. I'm one of Snap-on's National Diagnostic Technical Trainers. Been in the training department. I'm starting my 10th year in the training department, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on. So I had about 30 different franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru. So I worked in a dealership, and I guess just over time, just became the default diag guy in the shops. I always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bin. Then before that, a bunch of other miscellaneous wrenching jobs, then a little over 25 years under hood experience for me. So speaking of electronics and electrical problems and intermittent problems, all things that I had a lot of time in when I was at the dealership. We're going to talk today about testing intermittent electrical faults, those fun intermittent problems that happen on the third Thursday of the month when it's 62.9 degrees out. The sun is at this certain angle. It does this. All right. So it's always hard to duplicate. Well, I don't know if it's always hard to duplicate, but it can be difficult to duplicate. And just having a good strategy going into it can help you in testing these problems and catching these problems when they only happen intermittent. So it's always a good idea, and I talk about this a lot, is having a good workflow. All the way from intaking the customer through invoicing the customer down at the end after our post scan. So of course, we want to capture the customer complaint. Then we want to take it on a road test and see if we can verify that complaint. That's pretty key, knowing if you can verify the complaint. And then we'll inspect the vehicle. Of course, you want to do a multi-point inspection, see if you can uncover the cause of the problem and or other issues. Pre-scan, of course, we want to check for codes and then actually do the diagnosis, repair. Oftentimes, we need to recalibrate, reset the system. And then, of course, our post-scan after the fact, after a confirming road test, we want to do that towards the end. But one of the most important steps, I think, in this topic for the intermittent issues is going to be in that intake customers. We need to determine what kind of complaint they have. And if you've dealt with customers bringing their car in when they have a problem, sometimes they're not the most descriptive, or sometimes they have these weird off the wall type descriptions that might not make sense to you. Makes perfect sense to them, of course, but it might not make much sense to you. So we need to determine, what kind of problem is it? Is it a drivability problem? Is it a no-start problem? Is it a noise? Is it a drivetrain, electrical problem? We're talking about electrical right now. More than likely it is, but the customer might not understand that it's an electrical problem. It could be an intermittent cutout of a power supply or something of that nature. And they just say, oh, the car does this when it happens. And then after, of course, you'd figure out what the problem actually was. But a good way to standardize this and make sure we're asking the right questions and make sure we can get answers that make sense to us is using a drivability worksheet, kind of like this one. I just pulled this one out of ShopKey. They have a bunch of universal type forms like this. So how often does it happen? Does it happen always, often, or occasionally? Usually occurs morning, afternoon, or anytime, right? So I know, okay, is it a cold start? Is it after it's running for an hour? What's the engine temperature, cold, warm, or hot? Is it low speed, cruising speed, high speed? How long does it take before it happens? What are the driving conditions? I'm not going to read through them all, but you can read them there. You know, what's going on inside while I'm driving. How do I drive as the customer dropping off the car? You know, do I drive hard before the engine's warmed up? Do I allow it to warm up? Do I park the vehicle inside or outside? And so on and so forth. And what is the outside weather when this happens? So using this standardized type form will allow us as technicians, hopefully, to understand a little bit more what's going on with the car, especially when it's those hard to get intermittent problems. Like I said, only happens every once in a while. I remember I had one at the dealership, and it was like it would set a cat code, but it would only set a cat code at random times, and the customer couldn't really figure out what the correlation is. So we ended up, it took a while to get through it, and a couple visits actually too to figure it out. But what ended up happening is it was something to do with when they took a certain route to work, they went past this certain radio tower, and it caused interference in the car, and it caused interference in the oxygen sensor, which ended up causing a cat code. It was the oddest thing that I had ever seen. But that's one of those weird intermittent type problems that would always end up in my lap. So we just got to get it fixed. We got to get it done. We got to make the customer happy, right? So we just have to go keep at it and go at it and think about it logically, and then we can figure it out. Especially when we're dealing with electrical problems, for sure, we need to understand different types of circuits. And there's a few different types of circuits out there. Of course, a circuit would be anything in an automotive world anyways. There could be slightly different definitions, but in the automotive world anyways, we have a positive and a negative side, and then it's going to connect to some sort of a load. And of course, we have a battery, alternator, what have you, providing the voltage and the current. So that is enough to power a load, and we have to have a complete circuit going all the way around, unbroken, low resistance, that sort of thing, in order to make it happen. So the most simple type of circuit is going to be your series circuit, right? So we have our battery there on the left. And of course, we know in an automobile, the ground is not usually directly attached to the load. Usually it's going to be attached to the body or something like that. So we're going to have it go to ground. And of course, we have another ground coming off whatever the load is. It's going to go to ground. Maybe there's a ground screw or something on the body or what have you. So we got power supplied. In this case, we got a little light, and the light will light up. And as long as it's got power and it's got ground. If we have any break in a series circuit, though, so in this example, something broken on the power side, not going to work because the power can't get to the light bulb. Same thing with the ground side. So if I have a problem on the ground side, power gets to it, but it's not going to make the complete circuit. So we can't light up that load. So in the simplest series circuit, just kind of point to point, positive to negative, if you have a break anywhere in the circuit, I guess maybe it might make it a little more challenging to figure out what's going on, because you need to see, where exactly is the break. Is it before the load? Is it after the load? Sometimes you can tell just by using a couple of little test probes, but just knowing how the wiring diagram works. Learning how to read a wiring diagram is very valuable. Next one's parallel. So in this case, we have a common power and a common ground on 3 different loads. So they are parallel to each other. They come off the same branch. They might branch over here or something, but they have a common power supply back towards the battery fuse box and a common ground. So if I have a break in the line before it splits, nothing's going to work. If I have a break in the line maybe part of the way after it splits, one of the loads will work and then the other 2 won't. So if I was looking at this wiring diagram and I discovered that I had 3 loads on one circuit, and I discovered one load is working and the other 2 aren't, well, now I know roundabout where the break in the line is going to be. So in this case, it's either going to be on the positive side or it could be on the negative side there as well. It just wouldn't, it would be more in a different spot. But anyways, power there, ground somewhere down there wouldn't work, because that has to still make it down to ground. But what if I have it on just one branch of the circuit, right? So it cuts off the power to the one branch or cuts off to the ground to the one branch. That's more what I was thinking of before. I'll still have 2 loads light up and then one of them won't. So in that case, I can tell where the break is. Well, it's somewhere in this branch because that part doesn't work, but everything else does. Or maybe it's the component itself. So it helps me narrow it down. So I don't have to be chasing the whole circuit. I can just focus on one little area, split it down to its most basic. And then we have a series parallel. So we have a partial series circuit here, and then it breaks off into a parallel circuit as well. So once again, depending on where the break is, if the break's before the series, it's going to be a problem. The breaks after this series, it's still going to be a problem because the voltage still can't get through. But if it's, say, over here, well, that one works, that one works, that one works, and that one does not because the break is somewhere over here, right? So being able to look at the circuit, see how it splits, where are there splice points in there? Oftentimes a splice point can be a failure point as well. And just think about, I'll show you some examples on a couple wiring diagrams as we look as well. And then once we understand what kind of circuit we're working with, where in the circuit we might want to test, how are we going to test it? Before we start testing electrical circuits, we need to know what's the operating voltage, or what's the operating voltage working. What is it? Is it AC or is it DC? Some of your newer cars could run on AC and some of the circuits with the charging circuits, mild hybrids and some full hybrids. 5 volt, 12 volt, 48 volt in the circuit I'm working on if it's a hybrid or mild hybrid. What circuit type is it? Is it series? Is it parallel? What's the component type? Am I working with a relay? Am I working with a lamp? Am I working with a horn or whatever? And do I have access to the information that I need? That's important. What information do I have? So in this example, we have a vehicle wiring diagram, and we can see here is the 5 volt reference circuit on here, plus a couple other things. But if this is a 5 volt power supply right here, we see we got a splice right there, S137. There's a splice. So it's going to, so let's say it's 5 volts coming in here. It's going to go out to some other component off the screen. It's going to go to this component over here, which is differential pressure sensor. And then it's going to come over here, throttle position sensor, right? And then if it was a manual transmission, it would break out the clutch sensor. But if I have a break here in the line, then the throttle position sensor will give me a problem, but the differential pressure sensor will be fine. If I have a problem in the differential pressure sensor, maybe I won't notice a problem in the other lines. Or maybe if I have a problem here. In this case, on this particular vehicle, the differential pressure sensor had a problem. It was shorted internally to ground, and it was actually pulling most of the voltage off the 5 volt line. If you checked it with it plugged in, the 5 volt line read about 0.4, half a volt, somewhere in that range. When you unplugged the differential pressure sensor, everything went back to normal. So they were able to discover, just by removing that problem of the sensor being shorted to ground internally, by removing that problem, everything went back to normal. So you have to consider, when it's on a 5 volt reference circuit, on a lot of manufacturers, they will share amongst many different sensors, components, sometimes even running through other components to get to where it needs to go instead of branching off. That's a possibility as well. So always look at your wiring diagram when in doubt and see what on the circuit works and what on the circuit doesn't. If nothing works, then you kind of know where you're going to start. If only part of them work and part of them don't, then we have to kind of split it up. I need to have component test information as well. If I'm going to actually test the component, I need the information on how to test it. So in this case, the crank position sensor on a Ford Explorer. And you can see in this case, this is out of our guided component test in our tools. So any tool with a scope meter function in it is going to have this guided component test information. So it'll tell us how it works, where it's located, where the best place to test it is. And then it'll give us a picture of the connector and what the wires on that connector do. So in this case, we got a positive and a negative. So if that says positive and negative, and we got reference volts and we got a return, that's probably going to give me like an AC type signal. It's going to kind of go up and down. What type of component am I working with? Is it a signal generator of some sort? Am I generating voltage with it? Am I generating a frequency with it? Am I generating a magnetic field with it? Is it a solenoid or a switch or a relay or a thermistor or a motor or an actuator? Any of those things are going to work differently depending on powers and grounds and so on, and what the expected operation is. So we need to understand what kind of component we're looking at as well. And we also need to know, how do we know this circuit can even carry a load? Because depending on what you use to test the circuit, it may lead you down the wrong path. I'm going to show you a couple examples of this as well. Well, let's think about like a battery cable, a big fat battery cable, positive cable. We connect an ohm meter to 130 strand copper wire. What do you think the readings? As long as there's nothing wrong with it, let's just say it's brand new, fresh off the spool. What's it gonna be? Well, it's gonna be pretty darn close to zero. Might not be exactly zero, but it's gonna be pretty darn close. And that indicates what? No resistance inside the circuit. Now, a volt ohm meter, of course, is going to send a little bit of voltage through. It's going to see if there's a voltage drop, and then it's going to tell us what the resistance is using Ohm's law. It does it all inside, of course. But as we would expect, a known good wire, piece of wire, 130 strands, it's going to give us resistance of almost nothing. Now, if we take one thin strand of that wire out and we put the ohm meter on either side, what are we going to get for a reading? Well, it's going to be the same, right? Because it is just measuring what is the resistance in this piece of wire that you connected me to. It doesn't know, the meter doesn't know whether or not it's 130 strands or it's one strand. It just knows that this thing that I'm connected to on both ends, it has X number of resistance, which is more than likely 0. But what if I have a frayed wire? Like this wire right here, if I'm on these wires that are together and not frayed, then that's going to work fine. It's going to give me a good reading. But what if it was only one strand left connected? It's going to make a connection. I'm going to get this. I'm going to get a resistance value of next to 0. But can it carry a load? Can one little thin strand of wire carry enough current in order to start a vehicle? Probably not. It's going to get really, really hot, right? So we can't just rely on ohm meters when we're checking circuits. We need to load the circuit. Oftentimes, what some techs will do is they'll take like a halogen headlamp bulb, like a sealed beam bulb, and they'll connect that on the power side. If it's really dim, we have a problem. We have a resistance problem somewhere in the circuit that's nice and bright. Then you can be fairly certain that the circuit is working correctly and it can carry a load, because a halogen, sealed beam headlight is a decent amount of load on there. So we should be, we'd be able to figure that out with the light. Also, a good thing to know is voltage drop, how to test for voltage drop. So in this case, we have our parallel circuit again. And what we would do is we just take our meter or a scope or what have you, and want to check through this across the circuit. So the circuit must be live and the component or load must be energized for a voltage drop to be measured. So we need to make sure, in this case, we have a couple dim light bulbs and this one's nice and bright. So if we were to measure here to here before we have this little resistance, right? We just measure there to there, we're going to get, 0.01. That's like nothing. If we move it over to the other side, though, we're going to see that we now have a voltage drop of about 1 volt. So max voltage drops, rule of thumb here, what we have, for on a high current positive side, 200 to 500 millivolts is acceptable at most. High current negative side, 100 millivolts voltage drop is acceptable. For PCM circuits, if I have a light gauge wire, like a little thin, like 24 gauge or so, 50 millivolts is acceptable. Low current with not as light a gauge, 90 to 100 millivolts, and then solenoid switch contacts, we're checking that. 300 millivolts is acceptable on that as well. So I know what kind of circuit I have. I know what kind of test equipment I'm going to use. I can check the voltage drop if I need to, check for resistance. I also need to think about other kind of, or just in general, how to diagnose computer-controlled circuits on a vehicle nowadays, because we got to think about it a little bit differently than we have in the past, especially if it's, say, a body issue. It's not necessarily even a body issue now. It's really any computer-controlled circuit. But in the case of a body control module, we have inputs and outputs, just like any other module on a car. We got inputs and outputs. We have switchers, sensors, and data coming into the BCM because it'll get data from other computers. And then it'll output motors, lights, data, functions, whatever it needs to do to move things around in the car. So knowing we have inputs and outputs, allows us to be able to use a scan tool more than necessarily a meter to check it. Of course, we'd probably want to use our meter as well, but we can use our scan tool to figure out where in the circuit is the problem. Is it on the input side or is it on the output side? And that allows us to split it in half. Takes less time than chasing all the wires down. We have to chase half the wires down. And then if we can break that down even further, even better. But here's an older model, early 2000s window motor, right? So we got our switch here with the relays. So we got down and up. If it goes one way, we got a window down relay that clicks over, and then it puts the window down. It sends voltage to the motor. We go up, it goes the other way. We got a window up relay there, and it'll send the voltage the other way through the motor, and it'll go up. So what it's doing is it's sending current through a relay in order to make that happen. So it's physically voltage going to it, and that's what causes it to work. On more modern vehicles, in this example, we have a left rear window switch, but you'll notice there is a logic board in. So it will send up and down controls to the motor. Now, of course, battery power still comes in. We still have grounds there, and it does still send the voltage through, but instead of using relays, it does it all on a chip now. So instead of grounding a relay or whatever, it's just going to send it through this logic board, and then it'll tell the motor to either go up or down. You want to get even more fancy. This is on a, I think it's on a Tahoe, but we have our BCM down here, and we have our left rear window there. And in this case, I press the switch down. The switch then sends a signal over a network to the BCM. The BCM then takes that data and sends a command down another network bus over to the window, which gives the command to the window to go down. Now, it seems a little bit more complex to me than that older system, but it's less moving parts, it's less failure points. It's all ones and zeros and data, right? But it seems to me overly complex because I got to send a signal. Okay, put the window down. I got to send a signal to the computer. The computer needs to see it and interpret it and process it, and then send a signal to the proper window and then roll it down. Of course, it happens in our mind instantaneously. It takes, milliseconds or whatever to happen because of the calculations, but it's not a direct connection anymore. You got to think about it that way. On pretty much anything mid 2000s and newer, it's not a direct connection anymore. We're not dealing with relays. We're not dealing with all that stuff. We're dealing with networks, network topology, LIN bus, things like that. And then here's another example. It's on a Cadillac, right? So everything in here is on a logic board. The switch is over here, and then it sends a signal into the logic board, and then the logic board sends the signal out. Actually, it's included with the motor, pardon me. So the motor and the logic board and all of that. So really the switch is just there to send a signal to tell it go up, go down, what have you. There really isn't a, you see, there's really no like power going in there at all. The power goes to the motor, power and ground at the motor, but the switch really doesn't have power. It has a ground, but it's just sending signals down a wire there. So it's a little bit different. So we got to think about it a little bit differently in that way. All right, so let's give you a couple examples on the scan tool here. So let's go into wiring diagram. So I have a 2012 BMW up here. And this is another example of common shared power. All right, so my mass airflow sensor, fuel tank vent valve, DISA controller 1 and 2, oil condition sensor, and the crankshaft position sensor are all on the same 5-volt referencer or the same power referencer. I don't know if it's 5 volts, but it has the same power supply. And if we follow that power supply up, you see there's a connector right there. And then it brings us back to the fuse. So it looks like it's 12 volts. So we have 12 volts there. And it's all sharing. So if my break is in this connector, if I have a problem in the connector, then all of these will have a problem. Might not necessarily be a full failure, but I will have a problem in all of those components at the same time. If my break is here, then it'll be these 3 components over there would cause me a problem. If the break is here, then these components over here would cause me a problem, and so on and so forth. If I have a problem in this section, maybe those 2 don't work. So it's going to depend on what the code and what the problem presented to me is. Now there's another line that does the same thing. So it comes off of this relay fuse, this fuse with a relay on it. 30 amp circuit goes off the page, comes over here, comes down. So it's a signal to the computer, so it knows when it's working, and then it comes down here. And we got multiple splices all in roughly the same area. And it runs the electric coolant pump, the map thermostat, intake vano solenoid valve, intake camshaft, and exhaust camshaft, and exhaust vano solenoid. So if anywhere in there is broken, so if just this solenoid was bad, then I know the problem's in this circuit. If these 2 things are bad, then I know it's probably somewhere in there, and maybe that might not work. I don't know. It just depends on what the problem is with the vehicle, I should be able to see, judging by the wiring diagram, where the break may be and where my problem might lie. And we know these breaks can be in weird spots. Maybe it's like right behind the cylinder head or something, that it rubs on it every once in a while. And when I do a certain, when the engine tweaks just right at a certain load value, then it shorts the ground and then it cuts things out. It happens. Inside modules, it bounces too much and one of the solder joints gets loose. It happens. So trying to understand, where everything goes in the wiring diagram will help you immensely, being able to kind of read through that. So that's one example with the wiring diagrams. What other information? Well, let's load this Silverado. It's a pretty popular vehicle. 5.3 VIN-T. They had hybrids back, mild hybrids back. Just gonna put all that up there, okay? And we'll see 1.5 million real world repairs we have data on for this. But with that, you can go into TSBs. And let's say body electrical. There's a couple interesting TSBs in here. So you can get some good information from these technical bulletins from the manufacturer. So if I go and look at this one, let's see. So this is, let's see. Some owners make a comment on a no crank concern. When clearing DTCs, we have these random P1 codes in there. Need you to replace this module because resistance instructions do not always indicate a high resistance and or short between the three-phase cables or the stator lugs. So this is on a vehicle that might have problem inside the stator with that. So we can clean them possibly or replace them. Don't necessarily replace this module with that. So that's kind of interesting with that. So all engines, and that could be a problem with stator issues, pitting and arcing in there should be replaced if that's the case. So you can see that's just from a bulletin. So this could be an intermittent problem somewhere in the stator because I have this arcing going on. That means they're loose. If I got arcing, I'm loose, bouncing around. So that is pretty helpful. Oops. How about this one? Intermittent, called out right there. Intermittent mill with reduced engine power. And what it is the condition may be caused by water intrusion into the instrument panel to body harness connector, which carries the accelerator pedal position sensor signals to the ECM and PCM. Water intrusion results in a voltage difference between APP1 and APP2 that exceeds a predetermined value for more than a calibrated period of time, setting this code. So if you weren't aware of that and you saw these codes, you might think, well, the accelerator pedal position sensor is bad. Now, if we tested directly the accelerator pedal position sensor, in this case, I would imagine, let's see. I would imagine it carries the signals to the ECM. So if I measured it at the ECM, I might see a voltage issue if it's wet. If I measured it at the component, which we always talk about as well, it might be good. So if I test the component and the component's good, but the signal's not getting back to the computer, then I know it's got to be somewhere in the circuit. And hopefully I would have checked my TSBs with that, P2138, and find that TSB, go through and say, oh yeah, okay, look at that. Wet. It's just all these little things that the manufacturers find. And water intrusion seems to be fairly popular on some GM vehicles just because of where they put things. I know there's another one I saw. It's because like one of the drains for the windshield drains right on one of the computers. I don't know. Questionable design, if you ask me. And then talking about, as I said before, what if we have a problem with maybe a ground harness on the back of an engine, right? So there's a ground terminal location for an engine ground. If I have a problem with that, if it's loose, if it's intermittent, if it's on the back here, see how it kind of wraps around, maybe it gets caught and it's rubbing here, that could cause an intermittent issue as well. So we just got to decide, is it a power problem, is it a ground problem? How intermittent is it? What conditions does it happen in? And sometimes you can tell what the actual problem will be just by looking at it. All right. So now once I have taken us a little while to get here, of course, it takes me longer to explain it than it actually would take in real life, but once I kind of understand what the customer complaint is, what kind of circuit am I dealing with, what kind of problem am I dealing with, I looked up maybe some wiring diagrams, maybe I looked up some TSBs. In that case, now we want to go to testing. So if you have a snap-on tool with a scope in it, so that's going to be any Zeus, any Triton, any Modus, any Varus, Vantage, Verdict, any of those tools will have the guided component tested. And this is a database of over 5 million tests for different components on most of the makes that we cover in the scanner. We also cover inside the guided component. But also note that there are built-in classes in here. So if you want more information on things like basic electronic components, like we're talking about today, 10-minute electronics classes, right? So things like amperage, resistance, diode continuity, different electrical circuits, voltage drop tests, that's all in. Battery drain test. Let's see if we go down a little further. I think we have a electric windows, force induction, 15-minute ignition class. So all these different classes, relay testing, that's important. Voltage drop diagnosis right here. So we can walk through different circuit examples. Here's a couple circuits and we can measure the voltage drop and see where the problem is. It's kind of like walking you through a little lesson on how to do that. So that's all in there, all within the tool, all inside classes and how to. Also in here, we're going to have our meter functions. Now, this is going to give you a good example of where I need to choose the proper tool for the job. Pretty much everybody's got a digital meter, right? DVOM, pretty much everybody's got one. And also inside these tools, it does have a digital multimeter as well. So if I go into volts DC, and I can see 4.99 volts for the signal that I'm reading. 5.01 volts. So it's fluctuating very slightly, but not much. But I know, because I know what signal I'm feeding it, I know that that is not a steady 5 volts right along. There's a dropout in there. There's a glitch in there. But the meter, the volt ohm meter, the digital volt ohm meter, won't pick it up because of how it's designed, because of the sample rate. So the majority, I think pretty much all digital volt ohm meters work on a very much slower sample rate than you might be used to with, say, a scope. So it's only checking maybe 4 times a second, 250 millisecond sample rate. So if it misses the problem, it's not going to catch it. Plus, it's on an average. So what's the average flowing through this circuit every time I sample it? So in this case, it is seeing 4.99 volts. And if I was just using a voltmeter to do this, I'd think, okay, that's fine. 5 volt circuit, that's fine. However, if I want to see a little bit more detail what's going on, we also have a graphing multimeter. So it takes those numbers and it plots them over a period of time at a much longer time base and a much slower time base. And now we can see there is a glitch in that signal that we would not have seen if we had just used the ohm meter. Now, why is that? Once again, like I said, it's that average and the slow sample rate. So in this case, it actually draws it out and it takes more information. So it has a much better sample rate. So we can see there's a glitch. Now, of course, it's steady because it's on a signal generator. It just generates a glitch every couple seconds or so. So we can see that on the screen. Now, if I wanted to see even more detail, of course, I can go into my full-blown lab scope. So if we just go to volts DC and we have that on the screen, now we have, we can see there's my glitch on the screen as it happens. Now this is on a trigger. And the reason I can catch this is because of this trigger point. This trigger point does a few things for us. I'm going to walk through a couple different scenarios with this trigger. So as long as this plus sign is somewhere within the pattern, whenever the glitch happens, it'll catch it. It'll freeze it on the screen. If I bring it down below, now it's not catching anything. Now I don't even have anything on the screen. And this is a common call we'll get at tech support is, hey, I'm using my scope or whatever, and I don't get anything on the screen. And a lot of times it will be due to the trigger. So in this case, I have it set on what's called a manual trigger. So if I go to auto trigger, well, now I get a signal. And if we're lucky, if we sit here long enough, we might see that there might be a glitch in there. We wait long enough. Sometimes we will, sometimes we don't. Oh, there it is. So it depends on the sample rate and where it's hitting and where the glitch is hitting based on when the screen is refreshing and where the scope is refreshing. So as of right now, I saw it over here once really quick, but I want to be able to catch it. So since I have it on auto trigger, I can move this trigger up. And what it'll do is it'll catch it. Every time it happens, it's going to put it on the screen. And then it's just going to continue recording. So you see how it kind of flips on, flips off, flips on, flips off. It's just waiting for a signal to hit it. Once the signal does hit it, it puts it in the screen wherever that plus sign is. I can move it over here. You'll see it happens over here. Boom. Move it over to the left. Same thing. Happens over there. So it's going to depend on where it is. And then, of course, when it goes outside the pattern, it's not going to catch it at all. If you're lucky, you might see it happen on the screen. So we'll see that this is on what we call a negative slope or a falling slope. So it's going to catch it on the way down. If I flip it around and go the other way, it's going to catch it on a positive slope. It's going to catch it on the way up. You see how it kind of catches it on the backside on the way up. So we need to understand, what are we looking for? Am I looking for that voltage to drop out? Or am I looking for an excessive voltage situation where I got to short the power where it might be going up? We just need to decide. So that's on an auto trigger. On an auto trigger, I can also do this. I'm just kind of unclipping it real quick, and we can see how it drops down. Now it's an auto trigger. It's going to keep recording. If I go back up to my setup and go to my trigger and go to a manual trigger, notice how it freezes it in place. Now, if you look really carefully, you'll be able to see that glitch change every so often. Now let me turn off the glitch and set it back to normal. Now I have to start recording again. Now there's nothing. So if I'm waiting and waiting, if this is a glitch that happens 20 minutes from now, once it glitches, I will see it on the screen because of where I put that trigger. So in this example, let's just unclip it real quick, real fast. And there we go. I caught it on the way down. As soon as it crossed that trigger point, I could see it. Now that's a trigger on the way down. If I go the other way, clears it out. I let go, nothing, 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 nothing until I reclip it. So on the way back up, it catches it on the way up. So if I'm trying to catch a short to power, I want to do it upwards. If I want to do it on a short to ground or a lack of voltage going down, I want to do that. So that's about as fast as I can. We can see when it crosses that threshold, that's where it's going to catch it on the screen. It's going to stay there. So if I wanted to catch something happened however long ago, I can go in here and I can just leave the trigger set up on a manual trigger, let it roll, go do something else, do an oil change, do a brake job, whatever, come back. Oh, hey, there's something on the screen. And what happened? Oh, it shorted to ground. All right, so now I need to figure out where the problem glitching it to ground is. So it allows you to save that time and go do something else. Make yourself a little more productive when you do that. Plus, it helps to catch it. You can do it on a road test too. I'm driving down the road and then I'm trying to catch it, but I don't want to watch the screen, right? So I can go down the road. All of a sudden, there it is. Catches it on the screen, right? Pretty helpful, I think. All right. So that is my time for now. Hopefully we picked up a few little tips and tricks on that aspect of things. I think I say fun, but I say fun in a sarcastic way, of course, because you're always pulling your hair out in the moment, right? But to me, it feels like it's the more rewarding thing to diagnose because, oh, it only happens every once in a great while. And I was able to figure it out, and I was able to catch it, figure it out, help the customer, get them on down the road, and it never happens. So it was rewarding to make that happen. Let's talk about next week. Next week, we are on to our 48-volt mild hybrid vehicle operation and testing. So when I put together my battery and charging and starting system class end of last year, I had a small section on 48-volt mild hybrids because I hadn't really heard about too many of them. And I was very surprised at how many there are out there. You may be surprised at which vehicles are out there and how long they've been around as well. out there. So there was a lot of talk years ago, probably 10 years ago. It's like, oh, they're going to go get rid of 12-volt systems. They're going to go to 48-volt systems. So they got more power available and stuff like that. Never ended up fully happening. So they must have been talking about the 48-volt systems. So it runs some stuff on the car while there is still also a 12-volt system in the car as well. So we'll talk all about how they work and how different ways we can test it and different things about that. Same time, same place as always, every Tuesday, 6 and 9 Eastern. You go to snapon.com/OT to register and join on Zoom. Otherwise, the 6 p.m. Eastern class goes to YouTube, youtube.com/Snap-on Diagnostics. If you are watching this on YouTube, please make sure that you like and subscribe and ring the bell and all those good things to help out the algorithm with that. So we're already up to almost 22,000 subscribers as of today. So that's pretty cool. We're very, very close. We should hit that in another few days. I thought it was a big deal when we hit 20,000. That wasn't that long ago. So thank you for helping with the algorithm too, liking the videos, watching the videos, subscribing, telling your friends, all those. Also, the 9 p.m. Eastern class goes to my Facebook page. So it's facebook.com/SnapOnJason. You can give me a follow over there. All right. And then if you're interested in any of the previous topics in this series, everything from ADAS to those 48-volt mild hybrid vehicles, we have 62 different episodes in this series. They're all roughly that half-hour, 40-minute type length, and walk you through any of them, and they're free. So by my estimation, I never added it up, but by my estimation, since they're all about half an hour and I got 62 of them, that's over 30 hours worth of material that you can access for free on multitude of different topics, all on YouTube, all on our YouTube channels. Definitely check that out. All right, time for Q&A and comments. If you're watching on Zoom and you showed up late and you do have a question or a comment, just look at the top of the bottom of your screen wherever your Zoom controls are. You should see a Q&A button. Click on that, type in your question, and I'll get to those in just a second. I do want to also make sure I mention my buddy Keith. Keith is the other half of our training department. There's only 2 of us in diagnostics training, but we also teach 3 nights a week. So Keith does new product training Wednesdays and Thursdays. So Wednesday is going to be on Zeus. So it's from let's set up your tool. Let's make sure your Wi-Fi works. Let's set up your Snap-on Cloud account, etc. All the setup functions, talk about security link and all that good stuff. Then he walks through code to completion on a Fast Track Intelligent Diagnostics example, how this is going to help you diagnose cars faster, easier, better. And then after about a 5-minute break, after about an hour, spends another hour on the scope and meter function. So he'll touch on trigger, he'll touch on guided component test, and so on. So Wednesday's on Zeus, and then Thursday's a combo Apollo Triton class in that same format. So if you have Apollo or Triton, the scanners are the same. So if you're done with the first hour, that's pretty much the Apollo class, and then you can cut out if you want, or you can stay and watch the stuff about the meter. It's okay. But that's all available to you once again for free. He only does it on Zoom, so that way it can kind of be more of you can ask questions if you have any, have the tool in front of you, walk through it as he walks through it on the screen as well. Snapon.com/OT to register for that. All right, now it's time for questions and comments. Zoom looks like we're pretty clear today. On to YouTube. Quinn, welcome. Thanks for joining as always. And then, of course, he's laughing at the beginning because, like I said, I do say those fun intermittent problems, and they're not that fun, I know, in the moment. But, yeah, sarcasm, Quinn. And then at the caddy store, we'd have the customer ride with us to duplicate the concern, talking about getting the customer's complaint at the beginning. Absolutely. Definitely the best thing, especially if they can duplicate it easily. Get that going, have the customer drive it. Maurizio, hello. Ciao. Welcome. Dan Cujo, welcome. GIE Auto says different size light bulbs will give you the ability to load a circuit at different amperes. Absolutely. So I get a little 194 bulb versus like one of those big square halogen ones. It's going to load the circuit differently so I can tell what it needs. Anthony Nofi says, great presentation. No glitches. Thank you for that. He's got the dad joke book. It got in the mail. Okay. Let's see. Let's see. Richie James asked, did you do anything on intermittent grounds? We kind of lumped it all together. Powers and grounds and such. Maybe rule of thumb, less than 50 millivolt voltage drop. Okay, I'd say that'd probably be fine. What's a good ground voltage drop? I'd say less than 50 millivolts. We kind of went through it. If you rewind or kind of go back a little bit in the presentation, I mentioned when I talked about voltage drop, you can kind of go through that. Let's see. Yeah, he was a little late. Dan Cujo asks, does Mitchell and Shopkey Pro work on the Triton D10? It does not. And the reason it does not is because it doesn't have Windows, so it doesn't have an internet browser, right? So it does have Wi-Fi for some functions, but it doesn't actually have a browser where you can go out to the internet and check that. So you would have to, take the code or whatever information and then just punch it into Shopkey on another computer. So that's just where it is. Let's see. DJ says, excellent. I'll have to watch it over. Excellent. Dan says, what are the prices? I can't really tell you what the prices are on things. I can tell you list price on like Shopkey is like $175 a month without discounts, plus tax, of course. And then as far as price on the tool, if you want to change the tool, whatever, you have to talk to your dealer on that. Just because dealer sets the price. Let's see. Josh is asking, planning on having a parasitic draw classes. So trying to think back. If I actually did I know I didn't do a full class on it. I think I touched on it in a battery charging system. Didn't really talk about it this class. So yeah, good suggestion. I think I'm going to have to do one. So I'll put that on my list of things, Josh. So thank you for that suggestion. I'll do a parasitic draw class maybe in a few months. So I got my next 5 classes already set. So probably be, late summer, early fall. Probably be when I will definitely put that together. I think I got enough material for that. All right, good deal. So with that, looks like we've covered everybody's questions and everybody in the chat as well. I'd like to thank you very much for spending a little bit of time with me, taking a little bit of time out of your day, learn a little bit more about intermittent electrical problems and how we might be able to diagnose some of those pesky issues that come up on the 3rd Thursday of the month. So with that, hopefully we'll see you next week for 48-volt mild hybrid vehicles. You can learn a little bit more about those. Enjoy the rest of your week. Enjoy your weekend. Have a good night and take care.